In 1972, Gene Cernan stepped off the lunar surface, climbed the ladder of the Apollo 17 lander, and sealed the hatch behind him, the last human being to stand on the moon. Before he left, he said three words: "We shall return." That was 53 years ago. We didn't return. Not because we couldn't, because we stopped trying hard enough, because we built a space program optimized for politics instead of progress, because we let good enough become the standard when good enough was nowhere near enough. That just changed. In March 2026, NASA Administrator Jared Isaacman stood at a podium in Washington, D.C. with one word projected on the screen behind him: ignition. And what followed was not another promise, not another timeline that would quietly get pushed back every 18 months until everyone forgot what was originally said. What followed was a detailed, phased, technically specific blueprint for building a permanent human outpost on the moon. A real plan with real deadlines and real consequences for anyone who misses them. I've been through this plan in detail, and what I found is more ambitious, more technically interesting, and more strategically significant than almost anything in the mainstream coverage has conveyed. So here's what we're doing today. I'm going to walk you through exactly how NASA plans to build a moon base from the ground up, phase by phase, from the first uncrewed landers touching down in the South Pole region to a rotating crew of 4 people living on the lunar surface for 28 days at a stretch. I'll show you the specific technologies being deployed, why the South Pole matters more than anywhere else on the moon, what nuclear power has to do with surviving 2 weeks of darkness at -200 degrees Celsius, and why the most important sentence in this entire plan has nothing to do with rockets or rovers. This is not a vision statement. This is an engineering roadmap. And it starts with admitting that the old plan was broken. Think about building a house in the most hostile environment imaginable. No atmosphere, temperature swings of over 300 degrees Celsius between day and night, 2 weeks of continuous sunlight followed by 2 weeks of absolute darkness cold enough to freeze and destroy any electronics left unprepared. No supply store within 250,000 miles, no rescue service. Now imagine doing that while a competing construction crew is racing to claim the same plot of land, knowing whoever gets there first and stays writes the rules for everyone who comes after. That is what NASA is attempting, and they finally built a plan serious enough to have a real chance. The original Artemis architecture made a jump that no serious engineer could defend.